All right, please help me welcome Pat Martens from Bridge Preservation and Inspection Services. I'll be discussing evaluating the root causes of deficiencies in rigid cementitious concrete overlays. Thank you.
Presented at these conferences several times, and often I'll be talking about hydrodemolition and latex modified concrete overlay systems. But I thought maybe for this one I might try a little something different. Occasionally, I'll get questions about cracking in overlays or just deficiencies with overlays. And, agencies will say, well, these overlays don't work. Well, these overlays do work. They've been around a long time. A lot of these dense concrete overlays, and when we're talking about the RCCOs, rigid cementitious concrete overlays, we're talking about a family that includes like latex concrete, low slump concrete, your supplemental cementitious materials like your silica fumes and super densified concretes like Ohio uses, and there's other internal kind of mixes out there that various agencies have put together. And even the UHPCs we have lumped into that category. That's kind of a little bit different critter there to deal with. But I wanted to talk about, okay, so what are some of the issues that we see out there and how can we kind of alleviate those issues? Like I said, there's been lots of installations out there in the past, so we know they work, but when they don't work, that's what really frustrates owners and even the suppliers and contractors. So sometimes what you have to do is you have to bring in your private investigator to take care of it. Now, I don't know if any of you remember the old Columbo series. A lot of you may be too young for that. Columbo was, I think, aired back in the 1970s. He was a homicide detective in Los Angeles, but he could always use, the most minimal amount of evidence, and he could solve the case. And sometimes that's what you have to do here. You have to go back to figuring out, okay, what is our evidence out there that helps us to figure out what went wrong with our installation process. I grouped these deficiencies into three categories. One is the debonding or spalling, cracking is another one, and then scaling or just other surface imperfections that might be out there. Now, probably to do this topic justice, we probably need about an hour or more, so I'm not going that long, but what I'm going to do here is kind of I want to hit just one slide here on debonding, spalling, because I think that can be a little more self-evident as to what the issues are with that type of a deficiency. And really it comes down to, there's 3 points of initiation really as far as your deficiency. One, is it going to be below the interface, or is it going to be at the interface, or is it going to be up above the interface within the material? If it's below the interface, you probably have an issue with preparation, delaminations that didn't get out of the deck, micro fractures that are still within the deck. If it's at the interface, then we may be looking more at cleanliness issues, texturing issues, where you can get the good bond, and then within the overlay material itself, the material, what went wrong there or during the installation process possibly. But what I will say to the first two, and actually Joe and Gil kind of nailed it for me there, is hydrodemolition. That's what you really need to make sure you're getting all the delams out and you're having the excellent surface texture that you need to grab to. So, there's a lot of agencies here that have been using hydrodemolition for 20, 25 years or more. Some of you don't use it. I would say come on into the 21st century with us, and that's what you want to be using. You want to be using the hydrodemolition technology on these types of overlay installations. What I want to do, though, is spend most of my time talking about cracking, because I think that one is a little more mysterious to people. We have a lot of trouble trying to figure out just why are we getting cracks? And I am by no means an expert in this category. If I could figure it out, I could be rich. I could retire, and anybody could. But that's an issue for Columbo. We need to bring him in and determine, okay, why are we getting cracks? Why does concrete crack in our overlays? Well, a couple things out there. First of all, concrete cracks. We've heard that forever, and it's true. Concrete does crack, and especially when we have reinforced concrete decks. We've basically designed them to crack because the steel is going to take that stress. We also have, when we're attaching that overlay to the hydro-prepped surface, essentially we're reestablishing the slab. So that slab is basically acting integral now with that overlay attached on there. So it is continuing to act as the deck slab was designed to act. So where you have your high tensile points, those are going to be areas that the concrete is going to be susceptible to cracking, and that's why the steel is in there to take that load on. We also have restraint of the overlay with change in volume, especially the larger your pores are. You know, that overlay material is being, you know, it's adhering to the substrate. So if that overlay, as it's trying to contract itself, I mean, it's bonded, so it's being restrained. And then also just general loss of water out of the system, be it through the hydration process or dissipation of any excess water. So it's important to know what are the types of cracking that we have. We have, is it a structural cracking or is it a non-structural type of cracking? And when I'm talking about structural cracking of the material, I'm basically talking about like the live load stresses that are applied to our bridge deck. Like your truck traffic essentially is going to be really your live loading on there. There's also reflective or propagation. So if you have active cracking in your deck, and that overlay is attached to it, it's going to be acting in the same manner, and eventually it's going to want to propagate through if you have active cracking in the base deck already. And then thermal type issues, expansion contraction issues. Most of the time, I think in the structural type crackings, you're going to see those to be fairly straight line cracking. Could be longitudinal in nature or transverse, or it could be even diagonal, especially if you are on skewed structures. You'll often see at those long corners, you'll see kind of diagonal cracks run across there, but you're going to see more of a straight line cracking in there. And even under loading, the blue there is kind of highlighting the longitudinal cracking. Kind of hard to see without the highlighting there, but you've got loading issues going on there. So those are the types you're going to see with your structural type cracking. Now, the non-structural, I think, is what drives us a little more crazy because, you know, structural cracking is kind of hard to control. It's going to crack eventually, most likely if you have structural type cracking in your original deck. But when you get to the non-structural, that's what we like to try to avoid and reduce as much as possible. And that would include like your plastic shrinkage cracking. Plastic shrinkage is going to occur within the initial stages of the pour and during the wet cure period. Your drying shrinkage is going to be after you've taken the wet mats off, and when that concrete's drying out, and then you're susceptible to drying shrinkage potentially there. And then there's another category called autogenous cracking. It's kind of like plastic shrinkage cracking. It's kind of like a chemical cracking, but it's more relatable to concretes at lower water cement ratios, especially if you get to 0.4 and below, those types of mixes. They're trying to draw in water as quickly as possible, and that can lead to some microscopic type cracking that occurs within the overlay. So some of our reasons for the non-structural cracking, we mentioned about water cement ratio, and that could be either too low or too high of a water cement ratio. Delays in vibrating, consolidating your concrete, or finishing the concrete and getting the overlay into the wet cure stage. Pouring in unfavorable conditions or an improper time of day. And I'll get into that as far as evaporation. Then curing, delay in covering, getting that burlap on, and getting your concrete covered. Or just improper curing techniques, not having good saturated burlap that's being applied to the deck in a timely manner. And then also, not to be miss this, but the substrate itself. Often some of these materials require a very thoroughly dampened substrate, and that can be very important so that you're not robbing the mix that substrate's not trying to pull moisture out of the overlay itself. So those would be some reasons for some of your non-structural cracking. So this here, a little bit, this is pretty severe here actually, some plastic cracking. This is in a supplemental cementitious type overlay. Probably some evaporation type issues there. This one's a little harder to see, but there's some plastic cracking that's kind of developed. It looks like at the end of the pour, and you can see some discoloration in there. So again, this is where you kind of need to have documentation and a little bit of background as far as what went on, as far as during the pour, at the curing points. Did the mats, were they secured? Did they blow off at the end there? That could be a possibility. So you kind of need to be able to backtrack and figure out where, at certain key points, what may or may not have happened at the overlay installation. I'll talk about this evaporation rate because I think it's a pretty important part and something kind of a sleeper out there that I think people kind of miss sometimes because you're getting a certain rate of evaporation, and it's going to vary depending on the material that you're using out there. So as your concrete is hydrating, there is a bleed water that's going to be produced in the mix there. And when that rate of evaporation off the surface is occurring faster than what you're able to generate that bleed, then you run the risk of your shrinkage in that material there. And ACI has a nifty chart out there for this that you can kind of reference. And I'll kind of walk you through here. Well, it's kind of hard to see there on the screen, but it basically takes your air temperature, your humidity, your concrete temperature, and your wind velocity, and kind of runs it through a little nomograph here. So if you have an air temperature, say 65 degrees, and your humidity is 40%, you just basically run up vertically to the humidity line, then you're going to run across horizontally until you hit the concrete temperature, in this case 60 degrees, and then down to your wind velocity. In this example, it's 25 degrees. And there you can kind of translate over and get your evaporation rate, which is 0.12 for this particular example. So, like for latex concrete, for instance, 0.1 is often the threshold. Sometimes microsilica may even be a little bit lower, might be in the 0.05 range. And states vary, so you kind of need to know your state's particular rate. But something else to kind of show you with this, these, just a little bit of sway one way or the other. For instance, if you would add about 10 degrees to that concrete temperature, what you'll see is it basically just about doubles the evaporation rate there. So just little nuances like that within that chart can make a big difference in the evaporation rate that you're getting out of your material there. So some of the things you can do, though, to mitigate that, you can set up wind breaks. So if you have wind issues, you can set up some breaks at the site to kind of minimize that. Fogging equipment's often pretty popular on your finished machine to help kind of increase that kind of local humidity there. Reducing your concrete temperature, especially when it's in warmer weather. Applying an evaporant. Pouring at night is always suggested, especially with like a latex concrete, or very early in the morning. And that's probably good practice for really any of the overlay systems you're going to put out there for the most part. Or worst case scenario, you just have to postpone or delay the operation. I think when you see a little more pattern cracking like that, you can probably anticipate maybe there's some evaporation type issues that have happened in your mix. This particular slide here, if you look at the top, and this kind of shows you the importance of adhering to your specification, because the top slide, this is a rapid set mix with latex, and it's heavily cracked. This exact same mix, right below that, no cracks in it. And the only difference is they poured it out of spec. So it is important to really adhere to your specs. Drying shrinkage, that's something that's going to occur potentially after you've taken your wet curing mats off. And often that's going to be within the very top portion of your overlay. Sometimes if you do grinding and grooving afterwards, you'll see that you kind of grind and groove, and you kind of grind them out of there. They're often fairly shallow, but it's you'll see a lot of map type cracking as far as the pattern cracking. Same thing here, you probably have some kind of a drying shrinkage occurring in this particular case. And again, what's really key is the wet burlap cure is really essential, getting that on quickly and making sure it is thoroughly saturated as far as the condition of your burlap. This one here, I probably need a little more investigation on one like this, but it looks like you have a pattern type cracking that would be indicative of potential drying shrinkage there. And I'd be interested to see if there was any information on the actual curing. Did the mats get blown off there along that little 2-foot strip there? Just what may have went on there. Again, that's where you're really going to have to be able to dig into some of the things that went on prior to the pour. And that's what always makes it so difficult to try to judge this, as far as what happened is usually you're seeing it at the very end after the cracks are in place. You don't get to see what happened when they did the surface preparation, when they did the actual installation. So that's where documentation comes in real handy if you're fortunate enough to be able to have that. I wanted to show you one case study here that we had off a bridge, and this was a latex overlay, and on the left slide there, it's difficult to see, but there is some cracking in that. If you see the close-up view there, you can see the pattern cracking in there. And a researcher went in there and did a little investigation for us and pulled the core, and really that's the only way you're really going to be able to determine just what went on with the overlay installation there. Did it, if you look at that core, for instance, you can kind of see the crack coming down, and it's kind of going around the aggregate. And that would kind of tell you that that crack was developing in the plastic state. Whereas if it was coming through an aggregate, that would be indicative of a later term cracking potentially. So you can also see in this particular example, the overlay, it looks like the overlay thickness was a little over, almost 3.5 inches. So that's getting pretty thick for an overlay. And the aggregate size is also pretty small. So when you have thicker overlays, you'd like to have a little larger aggregate if you can get it. You also want to watch the size of your pour, because this pour was a very wide and long pour, so we had a lot of volume associated with it. So there was a lot of things that were kind of happening here that I think kind of had an effect on the cracking that was formed in there. So the study that was turned in from the research people, and you're not going to be able to read all this, but research, they get paid by the word, so they're going to write as much as they can out there. Basically, it talks about the unaccommodated drying shrinkage, and also as far as the restraint and curing going on there. So they kind of lumped a variety of things that potentially could have been at issue there. They did basically summarize and say the concrete itself was very high quality. It was good quality concrete, very dense. I went to the expert, Michael Sprinkle. I don't know if any of you guys, if some of you I know Michael Sprinkle. He's kind of the guru of latex concrete, or really any concrete overlay. He's been around this stuff for 50 plus years, so I kind of bounced this off Michael to kind of get his thoughts. And Michael said, this is classic plastic shrinkage cracking. It's classic of that, the pattern cracking, evaporation. So the evaporation rate most likely was out of spec when they poured them. What do you do with it? You can do localized crack pouring, taking an MMA or high molecular weight type material, epoxy. There's a variety of products out there you could use for crack chasing or flood coating. This is another example of a cracked surface. This happened to be a rapid set latex mix. Again, looks most likely you probably have some evaporation rate issues here. The agency went into the flood coat. I looked at this probably a month or so ago. This is probably about 5 years ago when when they actually placed the overlay. And I was out there and looked at it about a month ago, and it looked pretty good. Of course, all that surface material is worn off, but the cracks should still be filled. So kind of to get us to the close here, basically what you're looking at in order to try to minimize your cracking is, as far as plastic shrinkage cracking, I think evaporation rate is really big. Your drying shrinkage, you definitely, you're looking at curing type issues, so you want to make sure you're getting that good cure period. And even that, and even these kind of can overlap a little bit. You quite possibly, like in that case study, you probably had some plastic shrinkage, but then in addition some drying shrinkage that was unaccounted for as well. So you kind of overlap here. I think another good practice is when you are wet burlapping, go ahead and cover it with plastic. Help to lock that moisture in so you're not losing any of that moisture off there. Don't underestimate the deck saturation portion of it where that's required, where you want to have a good dampened surface on your substrate before you make your pour. I find a rapid set mixes really crave the water, so you don't want to be chintzy with it there. Longer and narrower, I think, works a little better than wider. The wider the pour, the longer it is for that finish machine to get across and to get your material covered. And then maximize your aggregate size when you can. And then structural type cracking, that's going to happen over time. Finally, installers. If you have good qualified installers, that can really leave a lot of headaches for you out there. But the bond is what's the key to getting a good long-term overlay, and so your prep is going to be really important there. And then cracking is going to be more the result of construction conditions and quality and the traffic and frequency than it is your material. We know the materials work. They've been out there for 50 years, and they've been working for us for a long time. So, and then nothing beats good documentation out there. And then finally, I'm going to make a quick plug here on the pocket guides. I think Nancy's going to talk about pocket guides here in a little bit. So we do have 4 pocket guides. They're out on the TSP2 website now, so you please go out there and use those. So.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.